Hey, and welcome to day 6. This was a pretty quick one, but we'll go through it anyway for completeness. So we're in a series of boat races. The first line is how long the race is, and the second line is the distance of the world record holder. The way this race works, though, is a little bit different. Is you have a button, you hold down the button, and every second you hold down the button, you get an additional meter per second of velocity when you release the button. So if you hold down the button for 1 second, then the remaining 6 seconds of the race, you're moving at 1 meter per second, and you'll cover a total distance of 6 meters, which is not enough to have beaten the world record. So the question is, how many options do you have to beat the world record for each of the ranges? So like in the first example, 7, 2 works because you would have 5 seconds where you would be moving at 2 meters per second, which is 10 meters covered. 3, 4, 5 also work. Again, 5 would be 2 seconds at 5 meters. So the same thing, but in reverse. And then you just do the same thing with the other ones and then multiply them all together. When I actually did this, I just hard-coded those numbers because my input was the same thing, just 3 sets of numbers. I was just faster than writing a parser, but I went ahead and put the parser in here for completeness. It'll be in the GitHub, of course. But basically, we'll take our first line, we'll split it on the colon, throw away the first half like usual. Then we'll split out the spaces, and then we'll filter out, because there's a lot of spaces in here, we're going to filter out all the empty strings, and then map the results all to a list of ints. And then we'll do the same thing with the second line for distances. So now we have an array of 3 items for times, an array of 3 items for distances. And then we'll keep our total ones, start the total ones at 1 because it's multiplicative, not additive for each set. And then for each race in the indices, time is our first one, distance is our second one, great. And then we're gonna try each hold for 1 at a time. So we don't need to bother with 0 because 0 times anything is 0. We don't need to worry about the top end either because same thing, doesn't matter how fast you're going if it's for 0 seconds. And if basically hold times the time minus hold, the race time that you're moving is greater than the record, then wins plus plus, and then multiply and return. We could be smarter about this and like only look at half the list and times 2 and stuff like that but it doesn't matter. This is such a short number of things, it's almost instant. So then for part 2, we're going to do the same. Well, the difference is there was bad printing or bad kerning or whatever, and they're saying that there shouldn't be any spaces here. It's actually just one race that's quite a bit longer. And so now it's going to be this long, and this is the max distance. My distance was also long, so I had to change it from int to long, but I copied everything over and just continued on. The difference here is, so we're gonna go ahead and pull out the headers, just throw them away, take just the numbers, split it on spaces again, filter out the empty strings, map it to int, and then I'm going to join to string with the empty strings. So basically this is going to concatenate all the numbers into a single number, and then we're going to convert that single number into a long, and then the same thing with the distances. You can of course go through here and remove all the spaces first, and then just instead of doing all this stuff, I had it in there already, so whatever. The difference of course is that we don't have to loop over each race every time, so that helps, but the races that we do have is going to be much longer, so there's a lot more things to check for. I think mine was on the order of like 50 something million or whatever, but in the end it doesn't really matter. Like that would take you a long time to work through 50 million possibilities, but not a computer. I mean, again, there's different ways to be smart about it. We don't have to do the whole list. We could just find the first, like binary search the first and last value that win, and then count the difference between the two. There's a lot of things you can do to make it faster, but the whole thing runs in like 42 milliseconds anyway, so whatever. If I get that down to 3 milliseconds, I don't care. Anyway, as usual, the code will be up on GitHub. If you got any questions, send me up in the comments, and other than that, I'll see you tomorrow.